Hello friends, welcome to Nabla online maths. In this video, we are going to simplify another index notation form expressions. And this is going to be the sixth lesson of the topic indices. So let's go through the example that I have on the board. And the example says, simplify x exponent 3n plus 1 all over x exponent 2n plus 5 over 2 times square root of x exponent 2n minus 3. To simplify this expression, first change the root sign to its respective index fractional form. What it means is that you have to rewrite this particular expression. And to rewrite it, we have x exponent 3n plus 1 all over x exponent 2n plus 5 over 2 times x exponent 2n minus 3 all to the power 1 over 2 or half. 1 over 2 is the same thing as the square root sign here. To continue, I will now have x exponent 3n plus 1 all over x exponent 2n plus 5 over 2 multiplying. Here, you can see that this is a power. This one is another power. And this bracket means multiplication. You know, we are going to multiply this power against this power. So to do that, I'll have x exponent 2n times half. It will look like this, 2n times 1 over 2. This 2 will cancel this 2. I will now have n times 1. And this will give me n. So that will be n here. Minus 3 times half. And 3 times half will be 3 times 1 over 2. 3 times 1 is 3 over 2. And here I'll have 3 over 2. Now, we can continue this by saying that x exponent 3n plus 1 all over. Now, looking at this, we have x to the power 2n plus 5 over 2 times x exponent n minus 3 over 2. And we have a common base here, which is x. And we know the first law of indices. If I have a exponent m times a exponent n, since I'm multiplying, I will quickly take one of the bases and then add the powers. That is m plus n. So this simply means that here I will take one base, which is x, and then add the powers. And here I'll have x exponent 2n plus 5 over 2 plus this power n minus 3 over 2. To continue, I'll have x exponent 3n plus 1 all over x exponent 2n plus n will give me 3n. Then we'll now add these fractions. 5 over 2 minus 3 over 2. If I have 5 over 2 minus 3 over 2, you see that I have a common denominator here, which is 2. I'll write it down. Then 5 minus 3 will give me 2. Then 2 over 2 is 1. This simply means that 5 over 2 minus 3 over 2 is 1. So I'll have plus 1. Then we can now conclude this by saying that this over this will give us our final result. And you can see that the numerator is x exponent 3n plus 1. And the denominator is also x exponent 3n plus 1. And we know that if the numerator is the same as the denominator, then the result will be 1. That is, any non-zero number divided by itself is equal to 1. And we can see that this is the same as this. So that means that my final answer is 1. So this is how we work questions like this. Maybe another person can solve this particular question by using different approach, but at the end, the answer must be 1. Even though you are using different approach, the answer will not change. Thank you for watching this video. If this is your first time of watching, please kindly subscribe to my YouTube channel, Nabla Mahami Online Maths, so that you will be notified anytime a new video is being uploaded. You can also share my Facebook post for others to watch. Thank you once again and have a nice day. Bye bye.